Hello everyone, and welcome to lesson number 3 in the Practical Python video series. Today we're going to be talking about imports. This means we're expanding the functionality of Python basically. All we've learned thus far is what I would call bare bones, maybe call it vanilla Python. The for loops, the if statements, everything, that's just the bare minimum programming needed to do anything with anything. If we want to do more stuff, we can do something like this. The math module, and some people call it a module or a library or an add-on or a package, and from what I understand there are very subtle differences between all of these terms, but just you can use them interchangeably, it's fine. So we're importing the math module, which comes with Python. If you downloaded Python, you don't need to download this separately. And then let's say we have a variable x equals 2.5, and then we want to round it. There isn't really a built-in just round function. There's something called ceiling and floor. So let me show you. Y equals math.ceil of x, and then we're going to print y. So ceiling means you round up, and floor means you round down basically. So save and run this, we get 3. 2.5 rounded up is 3. We do math.floor, that's rounded down to 2. Now what's happening here is this floor function is built into the math module which we imported. Python is very nice in that it's very, very lightweight. In and of itself, just the bare bones Python is very, very lightweight, in that even something as simple as the ceiling and floor function, you have to import this package. Bare bones Python doesn't have anything for that, unless I guess you could make it yourself. So if you want to run a Python script on a Raspberry Pi, a computer that's like the size of your thumb, then you can do that very easily. And Python is the language that people mainly use for tiny computers where processing power is of consideration. So that if you don't need this, then you just don't import math, and then you don't have this sort of overhead. Python can be very, very small because you can cut out and only use what you really need to use. Because we've done import math like this, whenever we want to use a function in this math module, we have to do math dot and then whatever the name of the function is. There's other things too, just while we're at it. This is square root. If we do like the square root of 4, save and run, that's going to be 2, of course. Notice how this is an integer, and then the math module converts it to a float when you're doing square roots. And there are a bajillion different functions that come with the math module. The point I really want to make is when you import math like this, you have to say math dot and then the function. You could do from math import square root or whatever function you want. And then, this is what I was saying. You can get rid of that. And now we get 2 again. So you're importing from the math module. All you're importing is the square root function, or whatever you want to do. You can do square root ceil. This means that you're not importing the whole module if you want to be really, really lightweight. Like if memory is very much is a very precious resource for you, you can import just specific functions from from whatever module. I've been using the math module as an example. It doesn't have to be the math module. From whatever module, you can import specific things. And when you do that, these names are going to be initialized. So you don't have to, and in fact you can't say math dot whatever. If you want to import everything from math, but you still don't want to say math dot whatever, all the different functions, you can say math dot import star or asterisk, whatever. And then if we save and run, of course that still runs. This means import and initialize everything from whatever package this happens to be. In this case it's math, but whatever. This can be nice for tidying up your code. You know that you're going to be using most of whatever package, so you don't want to go and list everything out from math import, ceiling and floor and sine and cosine and all the different stuff. Your import, you know that you're going to be using most of it, or this is just for testing, just for development. You know you're going to be using some stuff, you don't know what yet, whatever. You just say from math import star, and then you don't have to say math dot function all the time. Something to know though, people call this the star of death because you don't know what you're getting, basically. You don't know what I mean, with math, you pretty much know, but if you're using a package for the first time, you're just familiarizing yourself with it, you don't know what proper nouns, you can sort of think of them as, are going to be in this library, whatever. So, for example, there could be something in math that's called X, or that's called Y, or something else that I'm just using as a variable because I don't know any better. But it's actually, by declaring it here myself, I'll be overriding something in this module, so then something else in here won't work as well. Well, it won't work correctly at all. You could get errors and you don't know why. You could get just the wrong numbers and you won't know why. Just strange behavior because you switched something in here with your own thing because you don't know what it is you're importing. So there is safety in doing the math dot whatever, because that separates it. Like, for example, if I had like this, and then you put something in here, do some sort of a square root function, and this would need an argument. Now, since I do import math, by having math.square root, this does not override this. It doesn't overwrite it. Whereas if I do this, this would override it. Well, you couldn't have this then. And then that would override it, and it would cause problems. So it's just something to be aware of, something to be careful about, is how you import, what you import, etc. So that's about it for importing in general. Now we're going to talk about importing some specific things. So import OS, import shuttle. There we go. So these are two libraries that also come with Python. You also don't need to download these separately. These allow you to mess with external files. So an example of this would be, so something we can do, we do x equals os.path.exists. Folder, and we're just going to print x. So this is a built-in function in the OS package, and this is going to return a Boolean. Remember from the last lecture we talked about returning. So this checks for this file path. Remember file paths, like up here we have d/stuff, Python class, lesson 3, blah blah blah. So this is going to check for a folder. It's called a directory. It's going to look for a directory called a folder that's going to be in the same directory as this Python script. So I can show you. This is the Python script we're currently working on right now. And then next to this Python script is this folder. So if we save and run that, we get true, because there is a folder. But if we say like a folder 2 or whatever, just something that doesn't exist, we get false. That folder does not exist. We could put folders in this folder. So yeah, we'll do that. Another folder. We'll do folder 2 / another. Whoop. Okay, get rid of that 2. Save and run that. True, because there is this folder next to the Python script, and then within that, this exists, yes. So this is good for you have a configuration file, where a user can set settings for your program, and you want to read from that configuration file. Well, if you try to read from something that doesn't exist, you're going to get all kinds of problems. So you would first check, and we could do like config text. So this works for folders or files specifically. You would check to see if that exists, and if it doesn't exist, you could create it, and then just put like default values in there, and then from then on, whenever somebody ran your program, this thing would say, okay, yeah, there's a configuration file, I'll read from that and do whatever I need to do. Or if you're saving things, if your program creates images or creates text files of some kind, data, whatever, you'll have a folder called save data or something, and before you try to save something in that folder, you want to make sure that folder exists. And you don't want to go and make the folder if it does exist. So that's what this is for, in a nutshell. Something else, sometimes you'll want a menu to come up and like list all of the files because somebody wants to open files that they've already made. You could do is file. So this is going to return true if it's something .text or .exe or whatever the extension is, .py. If it's an actual file that can be read and stuff can be done to it, this will return true. Here, we'll put something in here. Config.text. So then you see this returns true. If we get rid of this, so we're just talking about the folder, it returns false. So this is false for folders, true for files. So if you wanted to list just the files that could actually be edited, then you would have this in a for loop or something to check to make sure it's a file, and then you could list those names. If a folder needs to be there and it is not, then you do os.makeDirs. So just to show you, this we know already exists. So we try to run that, we get an error because it's trying to make something that already exists. If we just delete that real quick, run this again, well, this returns none. This is what I was saying before, where built-in functions will return none sometimes. Because what would this return? It wouldn't make any sense. So you wouldn't set this equal to a variable. You're not using this to check anything, you're using this to actually do something. And that folder that we deleted before, it's back because we ran this. It saw this folder next to our Python script and made another folder in it called that. So if you had a folder, if you needed your script to make a folder to save stuff in, you would have it check to make sure it doesn't already exist, and then if it doesn't, it would make it. Now, if you wanted to remove things, there are two different ways to do this, and this is another use for the is file. You do os.remove. However, this is only for files, so we'll do make another text file in here. There you go. And if we run this, it just deleted it. There you go, it's gone. If you want to delete a folder, not just a text file, or whatever kind of a file, you do a different library now, that other one. I call it shuttle, I don't know what it's actually called, how you pronounce it. So rim tree, and that. So save and run that. Now that folder's gone. So just remember, not only is it two different functions, it's two different libraries for deleting folders versus deleting files. Now, if you want to copy things, for example, we'll just do that text file again. Do copy to that. Take this and put it in. Yeah, just there. Oh no. There we go. So this is going to find the file that's here and copy it from there to here. If we run this, oh right, because we didn't, that doesn't exist. That really doesn't exist. The folder doesn't even exist. Text. Now if we run this, then this is the one that we just made manually, and then up in here, our Python script just made this. Now, if you right click on something and you hit properties, you see there's all the stuff when it was created and modified, the size, all this stuff, all of this stuff. This copy to, there's like, I use copy to, but there's also like copy, and there's a bajillion different ways to copy something, and some of them preserve, it's called metadata, that date created and who made it and why and whatever. Some of them strip away that metadata and some don't. They all do very, very slightly different things. I've never bothered with it. If you just use copy to, that's fine. That's the practical Python solution, is just use that all the time. And if you want to move this file from here to here, it's just shuttle.move. Pretty straightforward. Now if we want to actually make files, now that we've shown how to move them around, make folders for them and everything, if we want to actually make a file, we do with open, we'll just call it this. As, call it this. And I'll explain what I'm doing in a second. So, what's happening here is open a file. This is the file path to it, so this is just going to happen right next to our Python script. This W means write. So when you open a file, you have to decide whether you're going to be reading from it or writing to it. And this means we're going to be writing to the file. That means that if this doesn't exist, it will make it exist. And if it already exists, then we're going to delete it and then make it exist. So that's what this W means. So with make a file as, I just made up this variable name. Do this variable name dot write. This is what I was saying, object-oriented programming. External file, well, ext file is a text file that we've opened here. And that has this built-in function write. And then we just put in a string. So if we save and run that, and we go here, we just made this, and we go in here, check out what we wrote. So like I was saying before, you can use this for a config file, or a bunch of other stuff. If you have data, if you have something that's churning through data, solving calculations, equations, whatever, and you need to save all that data, you would use this. There is another way to write to files, to open and then write a file. It's a little bit messier, and so I'm not going to go through it. And then the other thing is you have to manually close that file when you're done with it. But the way that we're doing it now, the with, open, whatever, it will close the file automatically when you're done with it. So that's really nice. Because the other way, if you don't close it manually, and then you go to edit that text file yourself, it'll say error, this is in use, and like all these problems. Not a fun time. So just do it like this. So this is if we want to write to a file, and remember this replaces whatever's already in there. So if we say like, look, it's new, save and run that. There it is. Whatever was in there before it gets deleted and just replaced. If we don't want that to happen, because we're doing something in a loop, and every iteration of the loop it's going to add a line to it or whatever, instead of writing to the file, we're going to put an A for append. So we'll put like, look, it's also new, just to show you that it's different. Save and run that. And we open the file again. Look, it's new, look, it's also new. It just kind of stuck it on the end. If we want to make it nicer, this would be where that break line comes in, the \n from the other lecture. There we go. Open this again. So it wrote it once, wrote another thing in there, appended this to the end. There you go. That's how you append to a file without overwriting it. Important thing to note, however, if you go to append to a file and it doesn't exist, you're going to get an error. You have to do this twice. So like, if you know the file isn't going to exist, you have to write it, and then you can append to it as many times as you want. And finally, if we want to read from a file, there are all different ways we can do that. So change this to an R for read. And we know that this is going to exist. Ordinarily, you would write it and then read it, or you would check to make sure it exists and then read it using the functions we used earlier. And then one way of doing this is just .read to x equals that, and then we'll just print x. This doesn't have to be in here. Run that. And then this is all that stuff that we just saw from inside the text file. Read just returns everything from inside the text file as one big string, including the break lines, including everything. Just one big thing. This has limitations. I forget if it's by number of lines or by how much memory or whatever. Generally, you don't want to use just .read. If you do .read lines, I think we have to convert this to a string. Read lines, instead of returning one big string with everything in the text file, this returns a list where each element in the list is a line in the text file. So if you look down here, it's a list. This is the first line. It includes the break line at the end. And then here's the second line, is the second element in the list. Now, if you know that what you're looking for is going to be in a specific place, there's another thing. 99% of the time I just use read lines, because it's just really convenient to work with. There is another thing, read line without the S. Be aware of this. I'm mainly telling you about this so you don't put this and then think that you're using read lines and then you're confused by the output. So read line takes an argument, it's a number. Save and run that. That's the first 7 characters in the text file. If we do a few more, save and run that. You see this is the first 17 characters in the text file. You won't usually be using this. I've used it a couple times because I knew that all the data I was going to be reading was going to be all on one line, like encoded. And then I would like pick it apart and like, oh, there's a T here, that means that whatever thing. So I would know exactly what the 17th element would be or whatever, and I would have code to handle that. So yeah, that's about it for the nuances of importing and then how to read and write external files. And I've used text files throughout all this, but you can do other kinds of files. Text files are just nice to work with for config or data or whatever, because they're very small. They open very quickly, they run very quickly. Now, because this will be of interest to my fellow engineers, and they're my original students, we're going to talk about plotting a little bit too, just real quick. So we're going to do import pyplot as plt. This is another thing I forgot to mention with importing, is you can import things as and then you basically make up your own name. This is just customarily people import this as this, and matplotlib is something that we had to download. This doesn't come with Python. There's another one, numpy. People usually import that as np, so that, remember before we did math.ceil and math.square root and whatever, you could import math as m and then just say m dot whatever, you know, in case something has a really long package name and you don't feel like typing that out or copy pasting it all the time. You can give it your own shorter abbreviated name if you want. Anyway, import matplotlib as plt, and then we're going to do x values equals just making something up. 6, 7, and then like 2, and whatever. Now we're gonna do this dot plot x vals and y vals. Oh, that doesn't go there. We'll throw this in there, make it look like something. Values. We'll do like, this is time, what we're measuring with respect to time now. And then always end with this. Save, run that. And we get this. You can see it plotted these values. I'm including this with the reading external files video, well, part of the lesson, because chances are you're not going to have your x values and your y values as lists in your Python code. You're going to be reading them from a text file with read lines, like I showed you earlier, how that returns a list. So ideally you would just have your x values on the first line and all your y values on the second line. But I found that things like LabVIEW usually export like x and then y, and then on a new line x and then y and then a new line and whatever. So I'm going to show you a nice little thing about strings, because when it returns things, remember it's a list of strings each line. So if we have, say this is the line that we get back from our text file, and we want an x value and a y value, make this line. Then we would do, we'll do x values and an empty list and another empty list. And let's say we have a for loop. Remember, we could do like for x in that thing.readlines, the external file.readlines. So then that variable is going to be each line in that thing. So let's just say this is what we got back. You can do x vals append. Remember the append function from before. Append line dot split. This is a new thing. This is what I'm introducing. 0. Oh, not that one. This goes out here. And we're going to be splitting it at the comma. And now we'll just do the same thing for the y values. Except switch this. There we go. So you'd have all of this right here in a for loop. So let's just say this was your first line or whatever, and you're going through, this value is going to change each iteration of the loop. So then this over and over is going to be running. We're taking this list, this global variable, xValues, dot append, so we're sticking into this list. Our variable, which is a string, dot split, takes your string, whatever you're doing dot split on, and then it splits it into a list of strings. It turns a string into a list of strings by splitting it at this value. And then because we have a list, we're taking the first element in that list and then the second element in that list. So this is going to be, this value here is going to be 2, and this value here is going to be 3, because we have 2 and 3. So if I show you that, convert the list to a string for when we're printing it. Don't always have to do that, but it's just good practice. And we'll print the y values too for good measure. There we get 2 and 3, and these are both lists. Actually, if we wanted to plot these, we would have to convert these to integers. There we go, run that again. Now we get lists of integers. So you would have this for loop running. You probably wouldn't be printing it, but you'd have the for loop around this running over and over and over again. These lists would be growing for however many lines there would be in the file. And then at the end of that, outside of that for loop, you could do this thing we just did before. So you would have these two lists, and then after that for loop, you would have this, and you could plot your data. If this is something you need to do, I feel confident in saying that I don't need to go through all the different ways that you can have a legend and you change the colors of all the things and change the labels and whatever. Because if you just Google matplotlib, you can find all that stuff very easily. This is mainly just so you can see the very basic example, a starting place, a foothold, and know that matplotlib is what you want. Just so you know what to Google, what to look for. And that's about it for this lesson. I hope you found it helpful and informative, and I hope you enjoy the rest of the series as well.